Hello all, welcome to today's class of the subject EC202 Signals and Systems under KTU syllabus. Today we'll be mainly dealing with Module 5 of Signals and System, where we'll be dealing with the problems under Discrete Time Fourier Transform or Dtft. In the previous lectures we had already seen what is Dtft, a brief introduction to Dtft, and we have listed out the basic properties of Dtft. So let's move on to the problems under Dtft. The first question is, find the Dtft of the following sequence where x of n is equal to delta of n. So the given function is nothing but the impulse function, that is the discrete time impulse function delta of n. We know that delta of n has got the value equal to 1 when n is equal to 0, and it is 0 for all other values of n. Hence we can write the Dtft representation as x of omega is equal to sigma n is equal to minus infinity to plus infinity x of n e raised to minus j omega n. And we know that n is equal to 0 means the value of function is equal to 1. So giving n is equal to 0 in the above equation, we'll get x of n as 1, and this is e raised to 0, where e raised to 0 has got the value 1, and this is also 1. So 1 into 1 is equal to 1. Hence we can say that the value of Dtft of the delta function is nothing but 1. Delta function on performing the discrete time Fourier transform will yield you the value 1. Now let's move on to the second question. The second question deals with finding the Dtft of u of n, that is the unit step function. We know that unit step function has got value 1 for n greater than or equal to 0, and it is equal to 0 for n less than 0. So we may write the equation of Dtft as x of omega is equal to sigma n is equal to minus infinity to plus infinity x of n e raised to minus j omega n. And as the function given is u of n, we will change the limit to n is equal to 0 to infinity, and we know that the value of x of n is equal to 1, and this will have the same form, e raised to minus j omega n. Now to the above equation we can apply the finite summation formula. It is of the form a raised to n sigma n is equal to 0 to infinity, which is of the form 1 by 1 minus a. Here the value of a is e raised to minus j omega. So u of n will have the Fourier transform of 1 by 1 minus e raised to minus j omega, because it is of the form 1 by 1 minus a, where the value of a is e raised to minus j omega. Now moving on to the third question, that is find the Dtft of delta of n minus m. This is actually a shifted impulse function, and we know that the value of delta of n minus m, the function indicates that the value of x of n is equal to 1 when n is equal to m. We know that when it is delta of n, it is equal to 1 for n is equal to 0. So here it is the shifted form of delta function. Hence delta of n minus m will have value of equal to 1 for n is equal to m, and the value is equal to 0 for all other values of n which is not equal to m. So this can be substituted over here. We know that x of omega is equal to sigma n is equal to minus infinity to plus infinity x of n e raised to minus j omega n. And we know that when n is equal to m, the value of x of n is equal to 1. So here x of n may be given 1, and instead of n you may give it as m. So x of omega is nothing but 1 into e raised to minus j omega m, because we are replacing this n with m. So we can write that the value of the Dtft of the shifted impulse function, that is delta of n minus m, is e raised to minus j omega m. This is actually a very important result that can be used in many of the problems. In the next section we are going to find out the Dtft of the shifted unit step function, that is u of n minus m. U of n minus m has got value 1 for n greater than or equal to m. For example, if it is u of n minus 5, then the value of this function will be equal to 1 only for n greater than or equal to 5. So we are giving the same value, and it has got value equal to 0 for all other values of n less than m. So substituting this condition in the basic equation of x of omega, we will get sigma n is equal to minus infinity to plus infinity x of n e raised to minus j omega n, and we can change the limit as sigma n is equal to m to infinity. If it was just u of n, the limit was changed to sigma n is equal to 0 to infinity. But here it is shifted unit step function, so the limit is sigma n is equal to m to infinity, and the value of x of n is 1, and this may be written as such. The next step, what we are going to do is, we are just going to expand this particular equation because it is summation. So we'll give the value of n as m, m plus 1, m plus 2, etc. So this becomes e raised to minus j omega m plus e raised to minus j omega m plus 1 plus e raised to minus j omega m plus 2. We are just substituting the value from n is equal to m to infinity, just some sample values. And here from these three terms itself, we can take the term e raised to minus j omega m outside. And the rest of the terms is written inside the bracket. So it becomes 1 plus e raised to minus j omega. E raised to minus j omega means e raised to minus j omega into 1. And this is e raised to minus j omega into 2 because this term is being taken outside. From all the terms, e raised to minus j omega m is taken outside. And so it becomes e raised to minus j omega m by 1 minus e raised to minus j omega. This is because this is again the finite summation formula we are applying. Okay. With the value of a is equal to e raised to minus j omega. Hence, we can summarize that the value of the Dtft of u of n minus m is nothing but e raised to minus j omega m by 1 minus e raised to minus j omega. The next question, we are going to find out the Dtft of a raised to n u of n, which is an exponential function. So we'll have u of n here. So we can change the limit as n is equal to 0 to infinity. And we'll write x of n as such. That is, x of n's value is a raised to n. And this formula is the standard formula, a raised to n into e raised to minus j omega n. So this becomes sigma n is equal to 0 to infinity. You can take this raised to n common outside. So it becomes a into e raised to minus j omega whole raised to n. This is again applicable for finite summation formula where the value of a is a into e raised to minus j omega. This is of the form sigma n is equal to 0 to infinity a raised to n, which is of the form 1 by 1 minus a. The value of a is a e raised to minus j omega. Hence, a raised to n u of n will have the Dtft of 1 by 1 minus a into e raised to minus j omega. Now, moving on to the next problem, delta of n plus 3 minus delta of n minus 3. We already found what is the value of the delta of n minus m. The Dtft of delta of n minus m is nothing but e raised to minus j omega m. That is a result that we already found out. So on applying that result, we'll get it as, if suppose this is delta of n plus 3. Delta of n plus 3 is your first term. Here you can see delta of n plus 3 is your first term and delta of n minus 3 is your second term. So delta of n plus 3, it will have the Dtft of e raised to j3 omega, and delta of n minus 3, it will have Dtft of e raised to minus j3 omega. So the value of x of omega is e raised to j3 omega minus e raised to minus j3 omega. It's of the form e raised to j theta minus e raised to minus j theta. We know that it can be written in the form of sine function as e raised to j theta minus e raised to minus j theta by 2j. It's nothing but sine theta. Here the value of theta is 3 omega, and taking this 2j to the RHS, we get it as 2j sine 3 omega. So that's all for some basic problems on Dtft. Hope you find it useful. That's all. Thank you.